Hello, and thank you for attending today's webcast, where we will be showcasing an innovative solution developed through the partnership between Information Builders and JETRO. Before we start, I'd like to cover off some housekeeping items. On the main webcast console, you'll now see the presentation slides in the center of your screen and the demo box on the right. These elements can be moved and resized to suit your screen using the icons on the top right-hand side of each menu bar. For your convenience, we have added resources and other useful items on the widget at the center bottom of your screen. Please feel free to check these out during the webinar. I'd like to now hand this webcast over to today's presenters, Boaz Raufman, CTO and co-founder of JETRO, and Andy Kirby, Senior Systems Engineer at Information Builders. Over to you, Boaz.
Hi, everybody. My name is Boaz Raufman. I'm co-founder and CTO of JETRO Data. And today I'd like to speak about interactive BI over big data. What is the challenge in doing that and how this is done by JETRO? So when we are talking about having interactive BI or enabling interactive BI over big data, we need to understand the uniqueness of the BI use case and why it is so different than other use cases that are handled by different big data tools and different big data SQL engines. And I will focus on three main differences and challenges. The first challenge of enabling interactive BI over big data is, well, the fact that we need to have it interactive. Unlike ETLs, reportings, machine learning algorithms that runs as a batch in the background, there is a person standing in front of a dashboard and waiting to get a response within seconds. This is very different than other use cases, and it creates very big challenges getting these responses in human interactive times, which means usually seconds. The second challenge is that dashboards created by a BI application generate a variety of queries. The dashboard is created by a business user. This business user is not supposed to be SQL expert. It just drags and drops the graphs and the buttons and the filters. And behind the scene, multiple queries are being generated using different dimensions, different joins, different filters, and there is very little control on what is being generated and how efficient it is in terms of SQL processing. And the third challenge, and I think maybe the biggest one, is concurrency. Every time a user does an interaction, hits a button on a dashboard, on a BI application dashboard, multiple queries are being sent to the processing engine for processing to return results. One interaction can generate 5, 10, 15 queries. And on top of that, BI applications are being used by many users, sometimes dozens, and in some cases, even thousands and tens of thousands. So that creates a very big concurrency challenge, unlike other use cases on top of big data, in which you have few users, maybe data scientists or specific experts, they just need to run specific reports. And I want to drill down a little bit to those challenges and understand how they are being handled today and why it's so difficult to resolve them with standard big data SQL engines. So let's start with the challenge of performance. We have business users trying to run maybe a simple dashboard, running it on top of a data set of billions of rows. And unfortunately, the system responds too slowly. So it goes to the IT, and the IT try to fix the problem, to the data engineers. So they start partitioning the data, sorting the data. They do various tricks, denormalization, pre-aggregations, pre-calculations. They're trying to rearrange the data, re-engineer the data to make this query return faster. That's one method. The second thing that you can do is increase your cluster size if you're running If you're running on Hadoop, for example, or using other big data processing tools, you are adding more and more resources. This means that you are spending a lot of efforts and times on your data engineering. You are spending a lot of time on adding resources to your cluster. And the problem is that no matter how much data engineering you can do, you cannot optimize all queries. You can optimize some scenarios, but then other scenarios will be less optimized. If you push to one direction, you have problem on the other direction. The second challenge, as was mentioned before, is the variety of queries. Maybe we were able to somehow optimize one or two queries, but we have multiple types of queries using different dimensions, different filters, different measures. So even if we do more data engineering and putting more effort there, we still end up with optimizing only some of the scenarios, putting more effort, more cost, and delaying application development because each time the application is too slow, we need to do more and more work in data engineering, data duplication, in order to make this application work in a reasonable interactive timeline. And no matter how effort we are going to put in that, we are always going to impose limitations on the application. If we are, for example, if we decided we are going to sort our data according to the, the event date, so maybe our queries that runs filtered by event date probably going to run reasonably fast, but there will going to be another query running filtering on top of based on customer ID. That's not going to be fast because we already sorted by a different column. So no matter how much we're going to play with that, we are always end up with limitations, and we are always going to slow down the application or impose limitations. That's the second challenge. And the third challenge is the concurrency. As I mentioned before, a single dashboard can issue multiple queries, and then we have many concurrent users. So if we are talking about big data platforms like Hadoop, they can maybe optimize to run 1 or 2 or 3 or 4 queries concurrently and use all the resources. But when you are throwing at them 10, 20, 100 queries concurrently, this thing breaks because of the structure and the method in which those engines are working. And for those of you that have tried to run interactive BI or tried to run BI on top of big data and have faced this challenge, I think many of you already understand why this is so difficult and have seen the challenges and the limitations that are imposed by those tools. Just really briefly, why the SQL engines, and I'm referring specifically to SQL engines on Hadoop in this case, why they are not fit for interactive BI. And I can refer to Hive, to Impala, Drill, Presto, Spark, and all the rest of the other tools. They're all general purpose SQL engines. They are very good in parallel execution. You can execute query and use all the nodes in your cluster and run execution in parallel. But the idea behind those engines is that you want to pull as many resources that you can from the cluster to execute your query. Each query will take a lot of resources. In the end of the day, those engines always fall back to full scan. You need to read 10 columns over 1 billion rows. Those engines will execute the query and will read 1 billion rows. And even if you manage somehow data engineer and sort the data, this will work only for some scenarios and will not work for other scenarios. So while those tools are great for ETL and reporting, and they can really process big data very, very fast, the cost is using a lot of resources, and that doesn't fit for the variety and the concurrency and the need for interactive performance. So the conclusion is that we need a tool that will resolve the specific scenario, the specific use case of interactive BI over big data. And this tool needs to be complementary to those engines. We are not going to try to build engines that will crunch bits faster than others. We need a tool that is complementary, that solves this specific problem, and let the other great tools like Hive, Impala, Drill, and so on to do the things that are doing best. So what are the requirements from this tool? First and most important, we need consistent interactive response times. Consistent interactive means that every query that is sent from the dashboard returns very fast. It can be under 10 seconds, can be under 5 seconds, but it needs to be consistent, because if the dashboard sends 10 queries All of those queries run in 1 second, but the query number 10 takes 50 seconds. That means that the user is going to wait 50 seconds. So it's all or nothing game. Everything needs to run in interactive response times. This tool needs to handle efficiently the variety of possible BI queries, the variety of possible queries that can be sent by different dashboards, not just specific queries or specific scenarios that the data was engineered to optimize. We need to have this tool using very little resources, minimum resources per query. Otherwise, we will not going to have high concurrency. If each query will take many resources, we are not going to be able to run multiple queries at the same time. Obviously, we need a solution that is scalable, and we need something that is automatic. It's not something that you need data engineering for. If you are going to do data engineering specifically for each scenario, you are going to end up either not being able to optimize your application or having a very limited application with a lot of effort invested in every new application. And also, in addition, I'm not going to get into that part, although it's very important, you need to consider that your data is not static. You cannot just pre-aggregate something and assume that you've done your work, because new data is keep added to the system all the time. So your system needs to handle ingestion of new data in a very efficient manner. So let's start talking about how JETRO approached this problem and how we solved this problem using JETRO tools. So the first thing that we understand in JETRO is that interactive BI is about visualization of data for humans. And that means that you don't need to resolve all possible queries and all possible scenarios. There are some things that define what is the relevant set of queries between all the possible queries on a data set, what are the queries that are relevant for interactive BI. Because this is, in the end of the day, the result set are presented to humans, it means that there is, we are going to see limited amount of data points. We cannot present to human 10 million data points. It's meaningless. So when you look at the type of queries being generated by a BI application, those are usually two types of queries. Either aggregation query that are grouped by relatively low cardinality dimensions. For example, we want a sum of sales grouped by store and state. We have maybe a few hundreds of thousands of stores, a few dozens of states, but it's still low cardinality aggregations, as an example. The other group of queries is queries that are filtered and can be filtered by either low cardinality or high cardinality dimensions. For example, we can filter by date. Okay, so we can have X hundreds of thousands of days, that's low cardinality. But we can filter by, I don't know, user ID, and maybe we have 10 million or 100 million users. So we can have different kinds of filters that are being sent by the BI applications. So those are the major two groups of queries. And when you are becoming aware that these are the type of queries that you need to handle, then you define a specific solution for that, and that's what we did in JETRO. To handle the aggregations, the low cardinality aggregations, we are using the concept of pre-aggregations or cubes, and I will soon explain a bit what that means. To handle high cardinality filtering, the example of select a specific user out of a data of a specific user out of hundreds of millions of users, we are using indexes. And the combination of using indexes and cubes plus a few other things is the thing that enables JETRO to resolve or most of the use cases or most of the scenarios within the interactive BI and big data challenge. The third thing that is very important in JETRO solution is the adaptivity. JETRO adapts to the queries, to the scenario, to the use case, according to the queries that are being sent from the dashboard, and automatically generate acceleration objects, be it indexes or cubes, based on the queries that are generated by the tool according to what the user, the business user, has built in the dashboard. So this means no data engineering. This means that we are adapting to different scenarios because we want the user to have self-service BI. We want the business users not to have limitations and not to be dependent on data engineering. Few words about the concept and where JETRO exactly fits. So JETRO is a transparent middle tier. It sits between the data and the BI application. The data can be reside on Hadoop, can be reside on different kind of EDW platform, on the cloud. JETRO sits on top of the data. It creates on top of this data the relevant cubes and indexes and cache objects and other objects relevant for the acceleration. The BI application will access JETRO using ODBC or JDBC and read the data from JETRO, and JETRO will provide the acceleration and return the results on top of the data very, very fast. How we make it fast? I mentioned the indexes, I mentioned the cubes. There is also a very sophisticated cache mechanism, columnar storage and columnar processing, and very smart execution. Using all those tools, we are able to return results very, very quickly on top of billions of rows. And as mentioned before, this is a self-driving solution. There is no manual data engineering. JETRO generates the relevant secondary objects for acceleration automatically according to the queries coming from the user, from the BI application. Very important point, again, to understand why we need both cubes and indexes, because there are some solutions that are cubes-only solution that are used sometimes to accelerate BI applications. However, those solutions are limited only for some of the scenarios, some of the use cases. When you need to accelerate aggregated query, low cardinality aggregated queries, cubes, aggregations are a great solution. But when you need drill down queries, if you need to filter by high cardinality dimensions or maybe multiple dimensions that together create high cardinality, I need to group by date and customer ID and store and event number and so on, then you cannot use cubes. Those aggregations become too big. They are becoming bigger than bigger as the data itself, so there is no point using them. And for that, you need indexes. In order to accelerate BI application, you need both cubes and indexes. One of them is not enough. Let's do a quick walkthrough of how this flow works, how things are being done in JETRO. So we have the data that resides, as I mentioned before, in Hive or EDW and S3. And JETRO is pulling the data from its location, creates the initial indexes and initial secondary objects. It has enough information to be able to resolve any query. The queries are coming to the JETRO query servers and are being resolved in the best way possible using the existing indexes, existing column, existing execution tools. And in the background, each new query is being sent back to a background service that analyzes this query and build additional secondary objects for it, adaptively creating new cubes, new indexes, according to what the users are asking us, according to the queries that are coming from the BI tool. Those cubes and indexes are being generated, being stored in the main storage. If you're working on a Hadoop platform, it will be on Hadoop HDFS. Another platform, it can be a different storage method. And next time queries are coming, they can use those new objects. So after a little bit of training mode, we have all the necessary objects to accelerate the application. Just a few words about the indexes and how JETRO indexes work. The most important thing is that to understand is that JETRO indexes are very efficient both in terms of creation of the indexes and use of the indexes. They are efficient enough that we can create an index on every column. Even if we have a table of billions of rows and multiple columns, we can still create indexes on all the columns. Those are, of course, not standard BTU indexes. Those are indexes, inverted list indexes that actually originate from the world of search engines and will change to fit to the world of database and aggregations. When you have indexes, when you can create indexes for all the relevant columns, that means that the more you filter, the faster the query gets. In other engines, as you add more dimensions to your filter, you need to scan more columns, your query gets slower. In JETRO, if you add more dimensions to your filter, you are just using more indexes, you are narrowing down your data set, that means that this query is going to get faster. And data set size doesn't matter, because if I use index, I'm only going to access the relevant values in the relevant rows. I don't care how much data there is in total. I care only what is relevant for my query. Also, the way that the indexes are built, you don't need to keep all the indexes in memory. You don't have limitation in terms of the index size, because the way the indexes are built, only the relevant index is used for each query. And so even if the index is very big for some reason, we can still maintain it persistent and access it very fast. Few words about JETRO AutoCubes with an example. So let's assume that we have a table called sale transaction in that case, and we have a state and some other columns and the value of a sale. And the BI tool generated a query, for example, select sum of sales where state equal Arizona. So JETRO will process the query, use the index to find all the rows that are relevant for Arizona, but let's assume that we have a very big data set here, maybe, I don't know, 20 billion rows. Even if we filter by state, we still need to scan a few hundreds of millions of rows, and this still takes a little bit of time. So after returning the result, in the background, JETRO will generate the aggregation. And the aggregation is, if we had a filter on state, we are now creating a table of all the states with the sum of sales. We are using the state that was used as a filter as the group by dimension, and we're using the aggregation, sum of sales, as the measure. We're creating this aggregation. This is done in the background. Next time a new query comes in, filtering according to this state or another state, doesn't matter. Instead of accessing the original data, the raw data, we are accessing the aggregation table, and obviously the aggregation table will be much smaller, and this execution will be much faster. So for low cardinality aggregations, this is a great method using the cubes. For highly filtered queries, indexes. Very important thing to understand about JETRO cubes. Those cubes are completely automated. There is no human data engineering. You don't need someone to create them. You don't need someone to guess what is going to be your application, what kind of aggregations or dimensions are going to be used. It's created automatically based on the queries that are coming from the BI tools. And when there is a change in the data, new data is added, some data is deleted, everything is maintained automatically in the background, cubes being updated, cubes being recreated, cubes being deleted. All maintenance is, again, also automatic. Instead of trying to create few very large and very complicated cubes in order to handle as many use cases as possible, JETRO takes a different approach. We create dozens and sometimes hundreds of smaller cubes that in each one of them can handle different sub-scenario within the BI application, within the dashboard. And because we have the indexes that we can use, can handle the granular queries, we don't need to create the large cubes. Because if you have high cardinality dimensions filtering the query, we will not create a very large cube on that high cardinality dimension. We will use the index because this is very filtering, and we can just scan few rows and get the results fast. Few words about the JETRO optimization process. And again, this is a topic that probably can be discussed for hours, but just in high level, JETRO is a very sophisticated optimizer. They try to rearrange and rewrite the query in order to make it run in the most efficient way possible. The main target of this optimizer is to get the query to use one of those three optimizations methods. The first one, little bit, the more trivial one, is results caching. If we already ran exactly that query and the data did not change, we can use results cache. If we ran exactly that query and the data changed, we can also use results cache in JETRO with a very sophisticated mechanism of an incremental cache usage by taking cache and running the query only on the delta and merge the results. That's one optimization. That's usually relevant for highly repetitive queries, the ones that may be generated in most cases, and when you start your dashboard and you haven't selected anything, you haven't filtered anything, you're just seeing the top view on your data. If the optimizer cannot use the cache, it will try to use either the cubes or the indexes. And this is done by very sophisticated query write methods, either pushing aggregations from outer queries to inner queries, pushing filters from outer queries to inner queries, converting functions to filters, converting functions on top of filters to a simplified filter expression so you can use index, moving joins, pushing joins, a lot of sophisticated query rewrites that in the end of the day will lead the optimizer and the execution to one of those three paths: results caching, cubes, or index access, and sometimes a combination. For very complex queries, it can be a combination of those methods. The bottom line of the way that JETRO optimizes queries is that the best way to speed a SQL query is to do less work. We are not trying to crunch the bits faster than Hive or Impala or other tools. We are trying to do the hard work in the background, prepare acceleration objects based on the knowledge that we are gaining from the application, and when the actual query comes, we are doing significantly less work, order of magnitude less effort, because we already have the cubes or the indexes to handle this query very, very fast. Just a few words about how incremental updates are being handled in JETRO. So both cubes and indexes are built to handle very efficiently incremental loads of data. Let's assume we have a 1 billion rows table that's already been loaded. It already have indexes and the relevant cubes. And then the ETL sends additional data set, let's say another 10 or 20 or 50 million rows. Cubes can be used in the query on the top of those 1 billion that we had in the beginning. And another part of the execution is running on the delta, on the new the set of delta rows. And then the execution engine knows how to merge the results from the cube and the delta and returns the results still very fast to the user because the effort was done on a small data set, only on the delta. And in the background, update the queue for new usage. Same true for the indexes. Indexes are built in blocks. And when new data comes in, a new block of indexes being created for the new data set can be used in the query. The old blocks and the new blocks can be merged, and in the background, this is merged to a new and bigger block. So the whole system is built to handle very efficient incremental updates. The way JETRO is installed, if we take the example of an Hadoop cluster, on one or more edge nodes. Those nodes don't hold any data. Those are stateless nodes. They don't contain any persistent information. All the persistent data, the indexes and cubes and so on, resides on the central storage. In case of Hadoop, it's going to be on HDFS. That means that we can bring up as many JETRO servers as we want because each server is stateless, and queries can be scattered across those servers. This means that you can scale very easily to hundreds and thousands and tens of thousands of users. And whenever you need more scale, you just need to add one of those servers, just pointing to the storage location of those cubes and indexes, and you can increase your capacity. Well, this is the customer slide, just a few of those logos. JETRO is installed in American Express, Royal Bank of Canada, and additional financial institutions, Avis, many companies, many organizations that provide health information to thousands and tens of thousands of users, and another large group of organizations and companies that are using JETRO in various scenarios, in various number of users, from a couple of dozens to tens of thousands of users that are using the application backed by JETRO. So a quick summary, what do you gain with JETRO? Very simple, you gain the performance. You can run interactive BI, real interactive BI on top of big data, get response times of seconds for all scenarios and for all BI queries. This is self-driving. You don't need data engineering. You are reducing the resources that are used by the cluster. You are loading off the resources from the cluster to few JETRO nodes and reducing taking off all the BI queries load from the cluster. So actually we are saving resources, and you're running your application as is. The application that you want to have or that you already have, you don't need to change it. You get it as is, but with interactive response times over big data. So that's it for the introduction on JETRO for me. And Andy, I'm handing it to you.
That's great. Thank you very much. Okay. Let me just share my screen. And hopefully you can all see the portal from WebFocus that's currently reporting against JETRO. What we have here is a classic high-level executive view of the data. We're showing just 1 year here for 1998, all categories and all stores. This data has, there's nearly 2.5 billion rows, as you can see from the heading in here. And this is reporting from sales data from a series of stores spread across the United States. And the data itself is going down to the SKU level. So there's an awful lot of data in here. We're pulling back not only items that people have purchased, but the colors, the size. There's a huge amount of data in here. And this is all running on my own personal laptop, which is a 2-core, 16-gigabyte machine. So the performance that we're getting from JETRO here is quite astounding. What we've built is a typical portal that an executive is going to see. I'm logged in here, as you can see in the top right-hand corner, as a JETRO executive. So I'm seeing all of the information all the way across the enterprise. If I was to log in as a regional manager for the East, for example, I would simply see the East's statistics. Similarly, if I was to log in for the West, I would simply see the West and whatever information and assets I was permitted to see. But in this particular case, we're going to have a worldwide view of everything, so we're getting quite a good view of things. So what we're doing here is, because it's an executive level, we're rolling the information up from this 2.5 billion rows to quite a high level. We have a series of KPIs across the top to tell me how I'm doing in terms of what the total net paid is, what the total list price was, information that people need to see rolled up to a pretty high level. One of the things that we see a lot in terms of adoptions for portals is people really need to be able to configure them for themselves. Real estate is at a premium for this type of an interface. So by having carousels such as down here, we can scroll between net profit, quality, and sales, getting the information that we need. We can hide information if we need to, so we can click here and simply take out the key performance indicators that we have across the top. We have mapping, which is becoming more and more important as people get GIS information within their data. They're wanting to put that up on a map and see what's happening, and they need to overlay other information such as household income or spending. That's all available through the WebFocus interface and partnership with JETRO. We also have some blogging at the bottom here, so if I see something that I want to share with other people in my community or in my peer group, I can simply enter in some blogging information down here, and that'll be shared by text and also through the portal for other folks. So having these high-level pictures and charts and textual reports is all very well, but often people want to see what's behind the numbers. And the first thing that they reach for really is drill down. Before we get to that point, though, you can see we've got some interfaces across the top here. And I should mention that this is all built using a thin browser, so I don't need anything on my machine. There's the only client that I need is a browser. I can log into the system and bring back all of this information anywhere and any place. One of the philosophies that we have at Information Builders is that for high levels of adoption, people really need to see things in a very familiar way. It needs to be familiar and in the flow of their daily lives. So what we've done is we've designed a series of systems and dashboards that really reflect what people are used to seeing on the internet today. For example, if you can order a book on Amazon or you can book a flight on Kayak, you should be able to use a system such as this without the need for training. That's how we get very high adoption levels, and we have people out there using thousands of users. So along the top here, I can switch the year. We can take a look at 2002, for example. Let's take this down to another category. Let's just take a look at electronics. And well, information builders is in New York, so let's take a little look at New York. So we can bring back the information just for those two categories and states. We bring the map back. And of course, as I taught, people want to be able to drill into this information. So let's drill into sort of the Monday sales and see how we did in terms of sales on a Monday. So the idea here is that you not only do you have the information rolled up to a level that gives you an overview of what's happening, but you can also drill into that information very simply, quickly, and intuitively, and bring back that information that you need to see. And here we can see we have a complete breakdown of everything that's been going on in New York. I can hit the reset button and resubmit this at any time. That just takes me back to the beginning and where I was before. Something else that people need to do is you need to be able to expand these out sometimes to get a little more information and see what's happening. And again, with this type of a chart, we can drill in to see what's happening. Let's take a look at Fairfield County. Here we're splitting the weekday and the weekend sales. Let's take a look at the weekday sales out in Fairfield County. As you see, if I hover over, I get a little more information with the tooltip. But just by clicking on that, I can drill down, bring back the information across the cities and see how the sales are doing. And let's take a look at Pine Grove. They don't look as if they're doing too well. They've had a bit of a down week. So let's just click on that, drill in, and see what's happening. And now we can bring back a tabular report as well. So we can really start to sort of pull the information back from this overview of how people are viewing the information and get into the detail. And again, Bose was talking about sub 10-second response. For 2.5 billion rows, I'm seeing 2 and 3, maybe 4 seconds for some of the larger ones. So it really is very, very impressive performance from that perspective. Again, we can refresh these and put these back to how we need them to be, with a simple reset and submit as and when we need. Talking about the map, obviously we can drill on the map. We can see down here that Alabama's suffering a little bit. It's down in the red zone. So again, we can take a look at Alabama, drill into that, pull back a more textual report to see what's happening, break things down a little bit. Subtotals, totals, we're breaking this out by the types of customers that we have. Are they a preferred customer or unpreferred customer? By the store type. And again, you can see the significant amounts of information that is coming back just for Alabama. Okay. Something I did mention was that this is built using a web browser. Today, we really don't know exactly how people are going to be accessing the information. They could be coming in from a laptop or a desktop, the way that I'm doing now. But more often than not, people are using tablets today as well as phones. So the Web Focus framework is built using a fully responsive framework. So if I reduce this down typically to the type of size that people would have with a tablet, we should see that respond. It doesn't look like it wants to. Looks like we're having some technical difficulties with the... let's just refresh this guy. I haven't tested this out with the presentation software, so I'm not sure what's happening. Let's just reload it. Okay. So you get a good idea of how long it takes to load these 8 different reports and charts with 2.5 billion rows. I think you'll agree it's quite impressive. So let's just try that again. There we go. If we switch that down to typically the size that people would see with a tablet in landscape mode, we can see that everything has been reconfigured. We haven't just provided a series of scroll bars around things. We're actually topping and tailing, putting these reports and charts over read. And if we reduce that down a little bit further, typically to the sort of size that people would see on a phone, then you can see that, again, we're rearranging the charts so that it makes sense. You can still interpret them, see the information, and simply rearranging them in the responsive framework. Okay, we take a look at the customer tab here. You can see we have a number of tabs across the top. Again, as we were saying, real estate is really the important thing when you have limited sizes on the screen to be able to get all this information in. So what we're doing here is we have, similar to what we had before, we have a series of filters across the top. In this particular case, you can select the actual dates that you want to use, so you can use the actual from and to date rather than just the year that we did previously. So it gives people a little more flexibility in terms of the dates and the calendars that they can use. And we can change the state that people are looking at. We were picking on Alabama earlier on, so let's take a look at Alabama. And again, we can pick out the different category. Now, these could be any filters at all that people need or people want to see. So it really gives us a lot of flexibility. Let's take a look at sports and just pull back that information. So what we're doing here is we have a slightly different chart on the left-hand side that's comparing male and female purchases across the states and comparing that with the states on the right-hand side in a textual report, which is still people need to see reports in text as well as graphics. As popular as graphics are becoming, we still see the need for people to actually get down and get the numbers and be able to use them as they go forward. Talking of textual reports, one of the things that we've introduced at Information Builders is the idea of in-document analytics. So what we have here is a report that's splitting out the sales right the way across all the states and the counties, rolling it up to store level. And we're comparing the year that's selected. So here we've selected 2002, and we're comparing that with the previous year. So we have the quantity, the list price, the net price, so the basic metrics of what we're looking at compared year on year. And then we have a little graphic on the right-hand side, a little thumbs up if this year was better than last year, and a little thumbs down if this year was worse than last year. So that's great, and we've looked at filters. But often people want to be able to analyze the data for themselves. And the most popular tool for doing that is usually Excel or a spreadsheet. Probably 99% of the time it's Excel today. So what we've done is we've built into the in-document analytics, we've built in something like 80% of the usual features that people use in Excel. So for example, I can filter this. Let's just take out the good years. So let's just filter on where we have a thumbs up. So now we have just the years that were better than the previous year. Something else that people do more often than not is sorting. So we can sort that descending by profit. So you can start to look at this data in a way that gives you the ability to find information in detail within here that you traditionally wouldn't find in a normal HTML type report or chart. Actually, speaking of charts, we can actually turn this into charts as well. So if I want to chart the net price, let's do that as a column and take a look at that across state. So I can create my own charts within this. And if you notice the speed of what we're doing, we're not actually going back to the JETRO server. JETRO's actually served up a data set for us into the HTML screen that we're looking at, the advanced in-document analytics, and we're running with that data set. And this is a terrific way to be able to give people access to information via email. We have a large number of clients that send out information like this to their customers or to the citizen or to their employees. And people are able to fold, spindle, mutilate, and look at the data for themselves. So once we have the chart, we have some further interactivity with that. So, for example, if I want to pick everything up that's in excess of 1.2 billion, we can just filter on that as well. So there's a lot of flexibility that can be seen within the in-document analytics that people are able to use. So that's great. We've looked at some initial dashboards, rolling the information up, being able to drill down. We've looked at some textual reports and how people can look at that data and use the in-document analytics to be able to analyze that further. However, with all of that given, we often find that people just want access to the data. And that's usually a challenge for IT to just give people access to the information. You never quite know how they're going to use it. So at Information Builders, we've developed the idea or the concept of something called guided ad hoc. This is a relatively simple screen. It's a relatively simple report. It's just rolling everything up to for the quantity to the country level. And we have a series of filters across the top. So if we change the state, we were picking on New York earlier on, we can just submit that. And we get back the information for New York. But that really isn't telling us too much because everything's rolled up too far. We have a couple of filters on the left-hand side. I can split it out by holiday sale or weekend sale. But what if I want to be able to dictate what measures and metrics I have on this screen? So we have the idea of a drop-down here where I can actually select the sort fields and the summation fields that I want to see. So let's say I want to see this price, net price, and net profit. And I want to see that by the states, the county, and the city. And let's take a look at the store name. So I want to go down to quite a deep level and see what stores are doing. I don't need the store country because I'm looking at New York. And let's just submit that. So now I get an entirely different report that comes back. So I'm actually independent as an end user here. I can create my own reports within the idea of the guardrails that have been put into place in the form of this particular application. And this is built using the new WebFocus page designer. I even have the ability to dictate what type of output I want. If I'm just looking at HTML on the screen, that might be well and good. If I wanted to maybe print this out and email it to somebody or share it with a client, I could select the PDF output. When I click submit, it comes back as a PDF. And we talked a little bit about Excel. Excel is still very, very popular. I can do the active report or the in-document analytics that we were just looking at. I also have the option to output this as Excel by simply clicking the button here. And when I submit it, it'll download a copy of the Excel spreadsheet. We can save that and then open that up. And you can see we get the report actually in an Excel format here. Even to the level that if there are formulas in here, we'll support the formula. It won't just be text coming back. That's a very popular output format for a large number, again, of our customers. So that's all well and good, but it's kind of built for internal use rather than external use. What if you wanted to give this out to maybe some customers, or you want to give this out to employees? It might be beneficial to have something that's a little more stylable. So what we can do is we can put an individual front end using HTML onto this. So this is a very similar screen in terms of the functionality. It just has a very different look and feel, and it kind of leads people through all of the options that they can take to look at this information. We have some instructions on the left-hand side that people can use. And then in terms of the sorts, again, let's put in the county, the city, and the store name. Let's take out country as we did before. And let's just put in list price. I can enter my own custom heading here if I want to. So let's just do JETRO heading for the demo. Again, we can change the dates up here very easily and very simply just by clicking on the calendar controls. We have the drop downs for the different formulas the different filters that we might need, categories, all holidays. And again, we have the different output formats that we might want to use. And just by clicking the run button, we can get that report back. And I think you can appreciate that by looking at the combinations and permutations of all of the different elements that we provide here, people can self-serve pretty much every type of report and output that they might need to see. It really takes away the need for IT to be involved in terms of giving people access to data or having people write reports for folks. It's a very flexible way of putting that information out and a very safe way of doing it as well. As I said, I have a couple of customers that actually describe this as giving people access to their data but keeping them within the guardrails. And then finally, we have the concept of a workbench. Because I'm a senior user here, I have the ability to access a number of different domains that we're looking at and a number of different reports. So if I have access to everything in here, I can simply run reports and create reports for myself from within this paradigm. Okay, that's pretty much everything I wanted to cover, Laura. Did you want to open it for questions for Boaz and myself?
Yes, so we'll now invite anyone who'd like to ask questions to submit those on the box in the screen using the Q&A widget. We'll give you a moment to let those come through before we conclude the webcast. Okay. Thank you, everybody, for attending today, and thank you to both of our presenters for that brilliant webcast. Thank you. Goodbye.
Thank you, everybody.